record this meeting. So it's recording now. So lucky I've said my joke earlier because it's not being recorded. Okay, not that it was a joke, it was an actual email. Okay, so let's open up Threshold 4. It's here in your notes, 2020-30 notes. So if you want to follow along, and I'll put in this recording as well. We won't spend too much time on this. We're in the front end anyway. We're just going to go to the back end of it. One thing I will note, I hope you all got an announcement from me today. I put in a must watch. This is the Khan Academy. You know I'm a fan of the Khan Academy. We refer to it quite a lot. But this link will take you here. I'll just show you quickly. We won't look at it. You can look at it yourself. But the formation of the Earth, the beginnings of life, the origins of life, and the hypotheses about life. What have we got? Probably 3 10-minute videos that are just fantastic. So please mark that. Make sure you watch these videos. They really explain aspects of Threshold 4 really, really well. Okay, so, and they give us a nice intro. So I've put that in an announcement, and I've also included it on Threshold 5 folder. Okay, the module 5 folder. A couple of other, oops, I'll leave that there. A couple of other things I've done, just lost my space momentarily. On announcements, you can turn them off, you know, if you're getting plagued with the announcements. I do encourage you to read them, but you can turn off the notifications. That's something for you to figure out how to do. Announcements, what did I announce the other day? That's really important, okay? Really critical. I'm older, of course, and a bit of a nerd and listen to Radio National like your dads and granddads do. My favourite Radio National show is a program hosted by Natasha Mitchell called Science Friction. And if you get their iListen app, you can go and listen to the previous episodes. I thought this one last week was just so good on COVID-19. It's a 30-minute listen. I've embedded it there for you. If you're driving somewhere or can't sleep, or you're getting into your study, or you're pondering COVID-19, please listen to this. It's just a really fantastic insight into COVID-19. It talks to a researcher who's an immunologist and also an environmental scientist, and he's been working with Chinese scientists for over 2 decades looking at viruses in bats. Because they're mammals and we're a mammal, it's really important we look at their viruses, and this documents the study of the corona family of viruses, including what we now know as COVID-19. Really fascinating stuff. Okay, also just keep an eye on your due dates, please. I know in the schedule, I have on this week, April 13, the online test. I just failed to remove that when I revised the test. But just have a look at these due dates. If you're not going to make those due dates for any of these assignments, please let us know ASAP. We're happy to give out extensions, but you've got to, it sounds terrible, but you've got to ask. Don't just assume you'll get an extension and hand an assignment in late. We're normally very generous. And in this particular circumstance we find ourselves in, we're even more generous. We don't need to know particularly the reason. We're authorised to give you a week extension, a 1-week extension without any documentation. If it's longer than that, I need you to fill out a special consideration form. But please let us know how you're travelling and where we can help before you get into trouble. Some people have asked, well, why don't we just put everything back a week? And I don't like doing that. And you people might like to comment in the chat room about this. Sometimes a deadline is a good thing, yeah? Sometimes deadlines are good because you know you're working towards something, and to have an indefinite deadline or a deadline that keeps moving can actually stuff up your routines. And having a routine is the best thing you can do for yourself in regard to your study. I know some people have found extra time on their hands, some people have found less time on their hands since we've gone online. I'm getting emails from students as well as to check their asses. I'm always getting some emails on just general advice on how to study. And the best thing I can say is develop a routine. And if it doesn't work, a routine. The best thing I can say is get a routine. If it doesn't work, get another routine. But just lock in little bits of study time. Just generally, you've probably heard from Brendan Murphy. And when I hear of Brendan Murphy, it reminds me about science literacy and to be a science literacy student. 3 cheers for Brendan Murphy, I say. He's our Chief Medical Officer, and with his state counterparts, they have done a fantastic job in advising us on what to do and advising the government. And to the most part, the government's following their advice. And if you look around what's happening in other countries, 3 cheers for Brendan Murphy. And something interesting happened the other day. Last week, Brendan Murphy was under a lot of pressure to release the modelling. Yeah, I don't know if you heard it. He was on the news a lot. People wanting to see the modelling. The press were getting antsy about it. The public were getting antsy about it. They wanted to see the modelling. And his reply was fantastic. His reply was always about evidence. I'm not going to, and this is not his exact words, but he was essentially saying, I'm not going to release the modelling until I have more data and more evidence that will ensure that the modelling is very robust. He said, I'm not taking any guesses. If I put it out now, I'm not convinced the data is strong enough to support it. So I'll wait till I get the evidence. And to me, that was a fantastic piece of public science literacy, a great message to us all. He was under enormous pressure there. He could have whacked out a model, but he held off as long as he could until he had the appropriate evidence. Really good example. At the same time, this bozo, no yay for him. As far as science literacy is concerned, I don't know much about him except he's a celebrity chef. And he's asking people, if you pay $15,000 to him, this is on his website, you get a subtle energy platform. I've got no idea what that does, but it revitalizes you and stops you getting, helps you resist corona. This is baseless, well-informed, and absolutely highly dangerous. Highly dangerous to the people who get sucked into it, and dangerous for you and I if people get sucked into this and they sit at home under their magic light machine thinking that they're okay from COVID-19 and then don't follow restrictions because of their magic fancy light. So really 2 really good examples of science literacy at work, and a reason why we need to be scientifically literate. Who are you going to believe? Okay, it's not because he is the Chief Medical Officer, it's because of how he approaches science that we listen to him. Or we don't listen to him, right? It matters on our health. Any comments? Have I been too harsh? Am I ringing a bell for someone? Have you seen something else like this? I'm looking in the chat section. Yay for Murph. I agree, Bryce. I'm always worried that in 9 months' time, people are going to be calling their children silly names like COVID. But I hope there's a rush on the name Brendan. Only one yay for Murph. Come on, guys. Someone disagree with me. I also want to show you in the discussion section, you'll like this one. Yeah, crazy, Eloise, absolutely crazy. And some people believe him because what he says sounds good. He sounds like he knows, but he doesn't. He doesn't. This is a really dangerous time. So what else I've done is in the thread here, and you can add to this, is I recently heard this as well. And this is a case where my science literacy went to work. I heard someone say this: Antibiotics used to solve every problem. And now one of the bigger problems the world has is this germ has gotten brilliant and that an antibiotic can't keep up with it. Well, here's my problem. It's a coronavirus. It says so. We know it's a virus. Antibiotics aren't used for viruses. Antibiotics are used for bacterial infections only. So straight away, that's like fundamentally flawed. Also, can a virus be brilliant? Well, there's even debate about whether viruses are alive or dead. It's really crazy. And again, the Khan Academy have a really great explanation. Well, they're not dead because it is performing biological functions. But if we look at what the biological functions are for something to be classified as living, and there's 7 of them, it fails 4 of them. So it's not dead, but it's not alive. They're cells, but they can't keep themselves stable. They don't grow. They can't make their own energy. But they can replicate and adapt to their environment. So they're quite complex. Any guesses onto who said these wonderful science illiterate words here? Take a guess. Someone who's in the media a lot said this. So I'm looking at the chat room again. No, it wasn't the cook, Bryce. It wasn't that cook. I love that. Yay, Jessica. Yay, Maddie. Yes, that was Donald Trump. That's an astounding thing to say, and for an astounding thing for people to think, you know, wow. So if you see any good examples or bad examples of science literacy, whack them in the discussion board, but don't just put them in, break them down like I've done here, okay? Just for a bit of fun, but that's scary and dangerous stuff. Okay. Right, now, module 4. Firstly, questions. I'll answer any questions about your AS assessment 3 or AS problems. Sorry, that email just cracked me up. So if you've got assessment problems, sorry, Kiara, I just can't help myself. I've got the giggles this morning. Okay. Any questions? I wasn't ready. Okay. Any questions or comments about assessment 3? Has it been useful, you know, considering the backdrop is a pandemic? And remember what I said, we get your surveys at the end of the session and they're really important data for us. But that's more helpful for next year's group, not so much for you. So tell me what you think about this assignment. Right, or something else. Referencing pictures, do we have to do APA or just links? Just links, I think, for now. Okay, this is your first big one. We've been really tight on it. We usually put in just a link or a credit to the person that owns the image with the image, okay? Look, if it gets messy, just put a list of credits at the end of your reference list. When we type in notes, is it more just speech style or are we writing how you would report? It's really up to you. Some people have adopted it as a real script. You know, this is what I would say. And other people has written it as a bit of an essay with using the slide. It's really up to you, okay? As long as you are referencing what you say. And I know people like to quote, and that's okay, but paraphrasing is much better. And I'll draw your attention back to what am I talking about with quotes and paraphrasing, what's the difference? Have a look with these, okay? It's really important. All right. Good questions. Anything else? What sort of issues? Exactly, Bryce. You can send me a draft if you like. Issues with...
Can you hear me, Jonas?
Yeah, I can hear you. Go for it, Bryce.
So, like, when I'm going through it,
Yeah,
and I've been going through the subject outline and all that stuff,
yeah, good.
I, like, with my last few assignments, even in other courses, I should just say, I feel like I've had so much direction. With this one, there is direction, but obviously it's open for like a little bit of interpretation, if that
Yeah,
makes sense.
yeah, that
I
is.
feel
Yeah,
like that's where I've really stumped myself because,
too much
like,
freedom.
yeah, I know, and I'm just so used to being like just like directed. I feel
Yeah,
like every time I go to do it, I don't want to waffle on or I don't want to stay on one thing too much.
yeah, yeah. Okay, and that's partly by design, Bryce.
Cool. I thought that was the case, just
Yeah,
with like over the last year doing it. I
yeah,
found that was what it was. And obviously it's hard to waffle on with the word count because like with each slide, if you're going over just say like 50 words, you might be running into trouble.
yeah,
So
yeah. So the challenge has been looking at the parameters I've given you, but still having to find your own way a little.
yeah, okay, cool. I
Yeah,
just like was making sure I wasn't the
yeah.
only one
No,
feeling like cool.
bingo. That's great. Um, yeah, that's really good because this is about developing your own science literacy too. And we've
Okay.
deliberately given you enough freedom so you can explore and then include what you think is right, what you think is scientifically literate. Does that make sense?
No, that's perfect.
Okay, cool. Great question. Thanks. Um, yeah, sure. And I just see Min responding to Eloise. We'll be able to get back to you as quickly as we can. If you don't have at least 15 slides, can we do say 10 slides with more notes? Yeah, you can do that, Maddie, but it gets a little bit messy. So just stretch out your slides a little bit. So when we're reading it, it's a bit easier to navigate. Yeah, even if you repeat a slide maybe, so you get an extra note page, that'll be okay. All right, that was a really good discussion, Bryce. Thanks for raising that.
Nice.
And that is the fine line we battle. And you'll find this yourself as a teacher. How much scaffold do you give? So students know what's expected, and then how much freedom will you give so they actually learn? So it's a really good point. And thanks for your input on that.
Do you mind if I just jump in one more time? Sorry.
Go for it. I'm delighted that you're talking.
So I have done like versions of this kind of assignment with other classes, I should say, where it's a presentation, but you have to walk the line of having not too much, whether it's in notes and then on the PowerPoint itself.
Yeah,
But in previous ones I've done, obviously, because I'm from an English background,
great.
all of it, they're just very boring and they don't want much as far as it goes. So obviously in previous ones you've been saying obviously not too much, but bedazzle it up a little bit. Like how much is too much? I guess is what I would like to know.
Right. Well, it's a
I'm
very
sorry
good
to
point.
fawn over this as well. Sorry.
No, it's great. I think it's a really good one. Really good question. I think it'll answer. And I see there's a fair bit going on in the chat that means onto that. Okay. Right. So your first point, one thing I pick up that you said was that you're English. You're an English major, or you've done a lot of English.
Yeah.
Yeah. And I think most of us have a strong background in languages and the arts, in education generally, right? We're really strong with that. And in those disciplines, you're quite rightly encouraged to use lots and lots of words. Yeah, be really descriptive, get the most out of language. In science, we are minimalists when it comes to words. We need to be direct, succinct, and precise. So it's nearly a whole different genre of writing for many of you. Okay, so we understand that. So generally with science, as far as words go, less is better, but to be accurate. I guess if you want to get down to the syntax, we've said that this is 15 to 20 slides with 50 to 100 words per slide. And if we add 10% to that, on the outside then, I guess 2,200 words is the max. And the minimum would be just quickly trying to add it up in my head. 1,500, no, 50 times 15. So what's that? 750, 10%. So 800. So on the syntax, we're around 800 to 2,200 words. And the reason there's that much freedom, Bryce, is again, to let people explore that space. So I haven't got a direct answer for you on the word count, but try to be succinct, and what you say should be supported by evidence from the literature. Does that help? You're still on pause, Bryce, if you're replying.
Yeah, no, that's perfect. Thank you.
Okay, great. Good-o. Okay, there's a whole lot going on in the chat room, but Min's onto that. So I'll let Min carry on with that, and I'll press on with what I wanted to get through today. Now with the modules, so Kiara looks like she's happy. Eloise looks like she's happy. Good job, Min. Okay, so we're up to our threshold 4. Okay. Then remember, when you're using our thresholds, you're in and out. You're in and out of big history. Okay. So it doesn't make any sense to do the module without reference to big history. Great question, Olivia, by the way. Yes, separate document for the reference list. So you will submit 2 PDFs. One, a PDF of the PowerPoint, and the other, a PDF of your reference list. And yes, EAST can cope with uploading 2 assignments. It's been proven. We already have a couple of students who have got their work in. Okay, so when you're doing big history, remember, we've given you the thumbnail sketch, okay, of the minimum stuff you want to do, you need to do. There's a whole lot to explore here in big history, and don't forget these exceptional resources down here. I've already pumped the tires up on Khan Academy, and this compositional and mechanical layers of the Earth is quite essential for our understanding of this module. They're all pretty good resources, but I think you'll benefit from watching this one, as well as picking and choosing what you need out of here. Alfred Wegener is a key player in all of this. He is to understanding tectonic plates and continental drift as what Hubble is to cosmology, as what Darwin is to evolution, as what Newton is to gravity, as what Mendeleev is to chemistry, okay? So we've got to have a good understanding of Wegener and his contemporary Hess. So what I want to do now is just this scoping exercise. So it's somewhat of a lesson, but more of just a guide to the, sorry, no pun intended, it's just a guide to the landscape, okay? So I'm just going to navigate you through some of the key knowledges that you need to get your heads in. Is that okay? Plus, I know you'll love this, I have a Kahoots for you as well. Okay, yay for Kahoots. Yes, Kahoots gets more yays and woohoos than Brendan Murphy. It's just funny. I'm going a little cabin feverish, I think. Anyway, right. Images are really important, and they're a really valuable way to learn. So just let's look at these images we have here on this slide. I know it's the front of the slide, and we're not going to spend much time on the front end. I want to get to the later sections of the stuff. Sorry, I've just got the giggles. I was going to say back end, but following my check my ass email, I don't think I can talk about back ends. Right, what's going on here? This is important. We have to understand how our solar system came about, and we have to understand how our Earth came about, how it was structured. So this picture is really good, and I want you to refer back to these pictures and tell the story of what's going on here. here's the early solar system, and here's the sun that's just ignited. And you can see this solar wave is pushing things away from it. All the debris was once in a big spherical or three-dimensional shape around the sun. Well, the forming sun, right? And through accretion is an absolute basic fundamental understanding. We've got to know what accretion is and how it works. So all this debris starts to spin, and as it spins, it flattens out, right? But gravity still works. Pressure on the sun, we know how suns will form. The sun lights up, we get this stellar wave. And you can sort of see here, you can get an image, the lighter material is getting pushed further away. But the rocky material, the heavier elements, are staying closer. And indeed, some of it has started to clump together already as planets. Yeah? And this is why the gaseous planets are the furthest away from the sun, the gassy giants are the furthest away, and why the rocky planets are the 4 closest planets. So that's a key understanding of accretion. If I just flip back into I showed this last week, this really simple demonstration to explain accretion. I'd encourage you to do this yourself, and I encourage you to explain accretion to someone else using this, because if you can understand something and explain it well and thoroughly to someone else, that increases your understanding of it. Try it. It's really, really important. But that's a great little demonstration. We won't watch it now. PowerPoint. Okay. So this story, we're building a narrative, okay? You're building this narrative like David Christian is building a narrative. And by the way, can I get to it? How is the, what's going on here? Maybe I have to open the subject outline. Damn it. How is the reading going? How is it going with David's text? I call it a text, but it's more of a novel. Good. People making progress on it, enjoying it. Is it helpful? It's funny. Most years I get a bit mixed bag on it. Some students love the book and some students can't quite get into it, but I hope it's useful. Any comments? Kaisha, good. I spoke to someone the other day who's got the Audible book of it, and they're just listening to it, which is fantastic. Don't be afraid. Who loves it? Who hates it? Who doesn't mind? Some comments? Not talking to me today. Thanks, Bryce. Neutral. Yeah. Okay. Not too bad. Yep. Yeah. I've had it for a couple of years now, and not everyone totally loves it. We get a full gamut of responses, but it's just another resource. Okay. But it does tell this story, and you're usually building your narrative too. So you should be, the ordering of events is good, Lisa. You should be able to look at these pictures now and use these as a stimulus for your narrative. You should be able to tell a nice story about this. If you can't do that now, you will be able to do that at the end of this threshold. Yeah, we are. Well, if you felt like an ant then, wait till we read this, what we do now. And similarly, the early Earth, this is what early Earth was like. It was a big ball of molten rock, very inhospitable, terrible, torturous place. In fact, we refer to this eon, and this is something we'll come back to, periods of time. We have eons, eras, periods, and ages. We need to sort those out. But this is in the Hadean period. And Hades was, of course, the Greek god of, and the Roman god of the underworld, hell, if you like. So this is the Hadean period. And it was a fiery mess. So and here it is here forming, yeah? And you can see what's happening. As it gets some mass, it draws things to it. Yeah, so we were peppered by meteors and asteroids. And if anything's standing in its way, it sort of gets swept up too. Planets were great. Think of a forming planet in a accretion belt or a proplid as a street cleaner. Yeah, so our orbit in Earth is clear, right? Why? Because our early Earth cleaned everything out for us. Okay. What else we have to get onto is understanding the mechanics of our Earth and how they interact. We have a core, we have an outer core, we have a mantle. Sometimes we refer to the outer mantle too, and the crust sits on the outer mantle. Now, the crust is broken up into tectonic plates, and there's currents, and we'll explain those in a minute. There's currents that occur on the surface of the outer mantle that push and pull these tectonic plates together, and this is what forms the Earth. Yeah? Okay. Also, we'll get on to the moon and how the moon was formed. And the moon was formed in the early Earth. There was another planet about the size of Mars called Theia. And Theia was collided with Earth at sort of glance. And again, the Khan Academy do a really good graphic on this. So this planet the size of Mars sort of clips Earth, and there's a big explosion. This gets knocked around. Lots of debris gets formed. Some of the ER stays in the debris. Some of it's on Earth. Some of it's in the debris around the young Earth. And it did something. It knocked the Earth on a tilt, which is 23.5 degrees. We're on a tilt on our axis, which is absolutely essential for climate, for seasons, for our climate, right? But then also all this debris resulting from that collision was around Earth. It went through its own accretion, yeah? All that debris started to spin and flatten out and then congeal into this little planet, this moon, okay? And the moon did the street cleaning job as well. And the moon's important for a few reasons. Apart from giving us that tilt, it actually stabilizes our spin, yeah? So we've got a nice steady spin 24 hours and we're around to the background where we were. We've done a full rotation. If it wasn't for the moon, we'd be doing all sorts of crazy spinning and wobbling and stuff. So here's for the moon. Right, so what I'm getting at, you should be able to start looking at these pictures now, and this narrative should build when you go to explain it. I'm going to zip through these recaps. They're mostly for threshold 1, 2, and 3, except to remind you that the next online test will have questions from all thresholds, 1, 2, 3, 4, and 5. Okay, there's more coming on 5 on life, but you've seen some of these questions, all right? And you're going to see some of them again. We're just adding questions from 1 to 4 and 5. So you might get questions from 1, 2, and 5 in your test, or you mightn't get many 4s and 5s because it's totally random. So you've got to get this coverage, okay? So these are good guide questions, but we're not going to spend any time with them now. And again, there's another really good image. Now, exoplanet is a planet that we think is a rocky planet, any rocky planet that's similar to Earth. And exoplanets are really interesting because there's life on our planet because we're a rocky planet and we're chemically diverse. That's what's really special about rocky planets. Now, there's not just elements, there's molecules, and molecules when elements come together, okay? Now, if there's an element in a rock and another element in another rock, the chances of them getting together and bonding is not going to happen. But if they're in some sort of molecule that allows movement, like water, then when we can get some more interesting stuff. So astronomers are really interested in exoplanets because rocky planets are more diverse, and they're really interested in finding traces of water or that molecule H2O or evidence of it on planets because they're the key to life. But so far, we only know of one planet where there's life. And I really don't think we're ever going to find another one. And we'll talk about that later. Okay. So I'm just going to go through some recap questions now and their answers. So if you've done threshold 4, this should be a good reminder. If you're heading into threshold 4, it should be a good way to get a handle on some of the knowledge. Okay, so we know from the early universe, hydrogen and helium made up the universe, right? 75% hydrogen and 25% helium with trace elements, just tiny, tiny elements of lithium, beryllium, and boron. Tiny, but important. So then we had first generation stars. We know the process, we know the story. And after first generation stars went through main sequence and supernova, the universe was a little bit more interesting because those first generation stars were element factories and they produced half a dozen more elements. When second generation stars were formed, they were made up of a richer chemical mix to start with. So when they went through main sequence and then supernova, it's after second generation stars we get all the elements in the periodic table. But still, after second generation stars, 98% of the universe, right, is still hydrogen and helium. Wow, that's phenomenal. But out of the elements in the periodic table, the heavy ones are really important. And for Earth, oxygen, silicon, iron, nickel, and sodium are really critical. Yeah, and we'll talk more about iron and nickel in particular. But when we talk about the heavy elements that make up the Earth and rocky planets, silicon, iron, and nickel. And when we get silicons and oxygens, we call them ciliates, and they're other types of rocks. So I talked about this before. You've got to know what a molecule is. So we know what an element is, and we get elements or groups of atoms that come together and they're held together by chemical bonds, right? So when we get a group, water's the best one, okay? The old H2O, right? Two hydrogens and an oxygen. Those elements come together, they bond chemically, and it's water, okay? And they're not like, water is not like oxygen or hydrogen, okay? Like molecules can be different from their parents, if you want to, or their base elements, if you like. But even within elements, there are different bonds. Carbon, carbon is the main element in diamonds, and the way the carbon's held together in diamonds is really, really strong. That's why diamonds are one of the hardest substances, natural substances ever. But diamonds are used in mining, for example, on the tips of drills, diamond drilling, because it's so hard. It can just scratch away at any rock. It's really, really tough. But when we see carbon can also be put together with really weak bonds, and think of graphite, think of your lead pencil. The carbon in the lead pencil, you just draw and those bonds can be broken really simply, yeah, without much effort. Okay, where do molecules gather in deep space? Well, around new stars, because new stars have enormous gravitational pull. Okay, so we do find elements, molecules in deep space. So yes, all the H2O we have, go get a glass of water now, or look at yourself, and we're mostly water. It was all born in space. Water is not a product of Earth. H2O is a product of space. We just happen to have a lot of it form, a lot of that molecule gathered around our star when we were forming planet, and then was included in the accretion process of our planet. A spectrometer. We've heard of spectrometers before. They're fundamental tool for measuring light waves, and Hubble used spectrometers to determine redshift, and we all remember redshift, don't we? Spectrometers are still important because every light source has a particular signature. Yeah, every gas and combination of gases burns at a different signature. So when we look at the light spectrum that comes from a light source like a star, we can tell what it's constituted of, right? And remember, we're doing an evidence-based story here, yeah? We're relying on evidence. So everything we've got is based on evidence. So we know our sun was formed from the debris of a supernova, and so were other suns. Our sun has siblings. we call, and this is an area of astronomy called galactic archaeology. And these spectrometers are still increasingly important. Silicates, I mentioned this before, oxygen and silicon make up the silicates, and most of the rocks on Earth are silicates. Yeah, we break them down and classify them as silicates. Right, so I've done that one, that's a bit redundant. How old's the solar system and our planet? Well, 4.567 billion years, right? It's not a guess. 4.567. It's like no magic numerology there. Don't go ringing Tom Cruise in the Church of Scientology and go 4.567. That's just the way it is, because we can measure very accurately. People often say 4.5, but if you round that up properly, it's 4.6. So 4.5, 0.46, you're not going to get murdered on each one of those. But the point is 4.567 because we have the evidence for it. We look at the decay, radioactive decay of elements. So we can really precisely measure the age of the Earth and the solar system. And that is just a little less than half the age of the universe, which makes me not feel so old. Okay, now we know the story of how suns formed, right? And now when we talk about supernovas, there's a huge release of energy when a supernova goes, and we see this through what we call stellar waves. Okay, so this is where we come into accretion again. So you can imagine a three-dimensional sort of clump of debris. What happens with this debris? It starts to spin. And we see this when we look at the Milky Way. We see this when we look at the rings of Saturn. This debris starts to spin and flatten out. Okay? And we call this two things, a protoplanetary disk or a proplyid. They mean the same thing, but they're used interchangeably. So sometimes you might hear a protoplanetary disk, sometimes you might hear about a proploid. Okay? And what happened at the center of the proploid? Well, that's where the star was formed. Now, let's get these percentages right. 98% of the universe is hydrogen and helium. Okay. Lock that away. That means everything else is 2%. Yeah. All the other elements are 2%. Okay. Out of that big cloud of debris, 99.9% of that debris, that section of debris of that supernova, went into the sun. That's just amazing. That means 0.1%, just 0.1% is the rest of the solar system. What? That's phenomenal. Thoughts? Comments? Or is it just me getting overexcited about this stuff because I'm a nerd and old and have a funny grey beard that I can't get long enough to put beads in? Let's hit the chat room. What's going on? What are your thoughts on this? Nothing. Interesting, says Caitlin. All right, yes, which is why if we go down here, again, Khan Academy, scale in the solar system is really important. All right, so this, you've got to get these figures right because there's more to come. Let's go. So the gassy planets are the furthest from the sun because when that solar wave hit, that stellar wave hit, it pushed the gaseous stuff, most of the gaseous stuff furthest away. Okay, and then it went through its own accretion sort of processes. Yeah. Now, Jupiter, Saturn, Uranus, and Neptune are the gassy giants. So remember, there's only 0.1% of stuff, debris, not stuff. There's only 99.9% of the debris from this thing, the debris from the supernova has gone into the sun. So there's 1% left. No, 0.1% left. 99% of that went into the 4 gassy giants. So that leaves 0.01% for the rest, everything else, the rocky planets and all the asteroids. So Bryce, how's your feeling like an ant now?
I don't know how to feel.
Hey? I don't know how to feel? Space is big. No one can hear you scream. It's phenomenal, isn't it? And we're just one small star in one small galaxy. Remember, galaxies are 10 to the 23, and inside each galaxy, suns are 10 to the 21. So 10 to the 23 times 10 to the 21, that's the amount of suns there are, and we're just part of one little one. And out of our little solar system, 99.9% of our chemical matter is in the sun. Anyway, I'm getting too excited now. I've got to watch my heart. And you know my story, if I have a heart attack, you send a mica unit, don't you? You do not send aromatherapy units. Okay? If you think I'm having a heart attack, if I go really quiet this end, ring the health emergencies, ring 000 and get a mica unit. If anyone sends me an aromatherapy unit when I'm having a heart attack, you're not going to pass the course. Anywho, so what do we need to know? Accretion involves spinning. We know that spinning we call a protoplanetary disk or a proploid. Left arm's good. I know the warning signs. I've been there before. Not that I've had a heart attack, but I have had a cardiac episode that scared the crap out of me. Okay, considering I have 2 brothers with heart conditions, both older. What am I getting? I'm getting distracted. Okay, so you should be able to know why the planets to the sun are closer, why the rocky planets are close to the sun, why the gassy planets are away from the sun. The answer is accretion. Right? The answer is solar flares, solar stellar waves when the sun ignited. It's all right, Cara, that was years ago. Just after my oldest brother had a heart attack. All right. Let me see. Gravity and electrostatic forces are key to this. You've got to get your heads into that space, folks. You don't have to be a physicist, but we have to understand the effects of gravity and electrostatic forces. Those forces get into a process called accretion, and the product of accretion is protoplanetary disks. Okay, right. So, the early Earth. There's a video on early Earth you've got to watch, and I've given you those links to the Khan Academy. We've got to understand the structure of the Earth, particularly how convection currents move. So let's talk about convections. This first little image, I'll make it even bigger. Oops, no, I won't. It's on the, get that one out of the way. Okay, you've seen this before. This is boiling water. Okay, little quiz question. Don't go to Google. Just the first thing that pops in your head. What are the bubbles in boiling water? Quick. Bubbles. Oh my God. Acids and bubbles. What am I doing with my life? What are the bubbles? Come on, straight away. There's, let me see, 19 of you out there. Trapped oxygen. Interesting, Cara. Okay, come on. First thing that you think of. There's no right or wrong. I'm just making a discussion. Kiara, thanks for responding. You're going to get a good mark because you're participating. That's what I said. Yeah. Interesting, Liv. You thought oxygen too, Caitlin. Good. Movement. Yeah, but what is the move? It is movement, but what are the bubbles, Liesl? What are the bubbles? Okay, anyone who knows the answer who may have been holding back, let it rip before I do. Let the answer rip before I do. Keep the mute button on if you're letting anything else rip. I had that little thing happen the other day in another meeting. Anyway, all right, what's going on? What are the bubbles? The bubbles are water. That's all they are. They're water. Water can exist as a liquid, as a gas, and as a solid. It is the only element that can exist in all 3 states. So what happens down here? It gets hot when molecules get, When molecules get hot, they expand. When they get cold, they contract. That makes that movement. But when water molecules get excited, they expand, they get really excited, and they convert from their liquid state to their gaseous state. That's all it is. And you know that we see the steam coming off. And you know that if you kept something and just let it boil, it would just boil dry because all the water would evaporate. So this is just water. It's an interesting little quiz, yeah? It's just water. Ask some of your friends and family and you know, about what it is and see what sort of answers you get. It's quite amazing. It's always incredible. Okay, so you get boiling water, you drop your spaghetti in, you can see it really clearly, can't you? As your spaghetti starts going around, it's the currents, convection currents, right? So the same thing's happening in the mantle, in the outer mantle. We've got molten rock and we see it when it comes out of volcanoes, okay? So it gets super hot towards the center, it comes up, it moves along, it cools slightly, it goes back down, and we start getting these currents, these convection currents. Now, what's sitting on, I'll just shoot up to here, back to the start. I shouldn't move these order. So this is where I said before, these convection currents, these currents now are pushing and pulling these tectonic plates. And this is how we get movement. The early Earth looked a lot different to what it was now. And the Earth is still moving. Australia is moving to the northeast. This way, you like holidays in Bali? Well, give us another 100 million years and we will be Bali. We're moving at 2 centimetres, okay? Oh, then they escape. Yeah, that's exactly right, Lisa. Yeah, they just turn into a gas rising to the top because gas is lighter than the water and then just freeing themselves. If they hit something, they convert back to their watery form. That's where we get condensation. Okay, so we're moving to the northeast. There's lots of activity on these tectonic plates. Oh, they're Bowen. Bowen, you know Bowen? It's a town in Queensland. Guess what it had just last night? An earthquake, a very quiet earthquake. So there's seismic activity all around the world all the time. It doesn't necessarily have to be on a plate line or a fault line to do it. Interesting, if we look at North America, and here's a fault line running along here. This is the San Andreas fault line. And that goes through Silicon Valley and all that sort of stuff. And a whole heap of nuclear reactors are built along the San Andreas fault line. That'll help you sleep at night. Okay. So, I'm full of bright news today. All these things to make you feel insignificant and lose sleep. Okay, so here's the molten lava doing things to the tectonic plates. Sometimes tectonic plates come together and they rise. Here's 2 continental plates coming together and they rose. Yeah, they made a ridge. This is called a divergence or a spreading. Okay, and its effect is constructive. Okay. Continental plates come together, Himalayas. Yeah, they're an example of continental plates coming together. And that mountain range is absolutely critical for life because they go up to such high altitudes. When the cold winds come down through China and hit them and blow up, we get rainfall, the orographic rainfall. And that gives rise, the Himalayas are the birthplace or the headwaters of the great Asian rivers, the Ganges, etc. Okay, which make life sort of possible and early life. What else can happen is when 2 plates come together, they can diverge, okay, converge, and we call this subduction. All right, you can see here one plate going under the other, and this is destructive. We lose land. Yeah, it goes underneath and gets melted and contributes to this cycle. So we get ridges arise, we get trenches going down. The deepest trench in the world is the Marinara. I think another mental moment. Someone Google quickly the deepest trench in the world, the Marinara. Sorry, seniors moment. The deepest trench in the world, and it's a result of this. Sometimes we get plates or fault lines rub against. That's it, Marinara. Thanks, Min. Of course. Who do we ask? Who comes to our rescue? The marine biologist. It's always good having a marine biologist on standby. Thanks, Min. Marinara. It was more a seniors moment than anything else. Okay, so so it's good to understand and know what caused the great mountain ranges of the world too. Okay, so again, this is what we originally, all the land masses were together. Okay, right, we'll clump together, and we broke off into Laurasia and Gondwana, and Gondwana is the great southern land. Australia's part of Gondwana. The southern hemisphere is Gondwana, and this is where our friend Wagner comes into it. All right, because he wasn't around then, but we know the world looks really different now. But at one stage, and we understand this now, at one stage all the continents were joined, and we know this because and Wagner was the first to cotton onto this because he was a meteorologist, so he studied weather. So he went to extreme places in studying the weather. That's why there's such a glamorous photo of him here. As a meteorologist, he went to, you know, way out places. So he found that, you know, when he's here on the north, south, east, west coast of Africa and the east coast of South America, he found that the stones, rocks and stuff were similar, you know, and he started thinking, oh, if I go to Africa, there's some stones here in North Africa which are the same as Asia and North America. There's some stuff here in Australia and Antarctica, some, you know, geographic stuff. It's the same. They must have been joined. And this was the birth of the theory of continental drift. Of course, he was a meteorologist, so all the geologists, they hated him because they said, this is our area. Go away. We don't want to talk to you about this. We'll think of this ourselves. Shut up. But he found more and more evidence, and others joined in and found more and more evidence. Okay? And someone who really helped out was Hess, because we had sonar was available, and Hess started looking at sonar of the sea floor. So then we started to get this version of understanding of continental drift. Here's the Himalayas, as I was talking about before. There's this two continental plates coming together, and this massive ridge being formed. And you can see all the countries along here, yeah? And this is the headwaters for all these great rivers of Asia, okay? So the functionality, the mechanics of the Earth is important. We also have to understand the value of the Earth's magnetic field, yeah? we're running out of time, so I'm not going to get into that very much today, but that's something you've got to get your head around. There's plenty of stuff in here about that, about the magnetic Earth. But I think, again, this compositional mechanical layers of the Earth is really, really, really critical. But understanding Earth's magnetic field and its function is really critical because it keeps us lots of real safe. You would have heard of the function of the Earth's electric field. Even if you've heard of the Northern Lights and you've heard of the Southern Aurora, that's when supercharged particles from the sun are shooting past us, and they're being deflected by our magnetic field. We'd be bombarded with radiation and all sorts of stuff without our magnetic field. And where we get that interaction on the South Pole and the North Pole, and that's where we get the Northern Lights and the Southern Aurora. That's that fantastic light shows we get. And that's that electrical activity of those supercharged and radioactive particles being deflected and passing through being deflected by our electromagnetic field. Oh, I'm talking a lot. Okay, so we have a really great field. Mars doesn't. Okay, so it's a good comparison, but there's plenty of stuff. Okay, I have to go. Sorry, John. Thanks, Fletcher. Hope that's okay and interesting. I am recording this one. Okay, so there's some objective. That's the stuff you need to know. We do a little bit on Europa because the Voyager spacecraft, which are now being in space for a few decades, they're in deep space. They've actually passed the outer rims of the solar system now. But one of the Voyagers actually, one went through the rings of Saturn, and you might have seen the Voyager photos of the rings of Saturn. That's an accretion disk in suspension, okay? the gravity of the neighbouring gaseous giants and the suns and the gravity of Saturn keep that debris in that protoplanetary disk sort of stable. Okay, so it's a stalled accretion process, if you like. And another one of the Voyager crafts went really close to Jupiter and really close to one of its moons called Europa. And Europa is very exciting because on Europa we see evidence of subduction. It's a frozen island, a frozen planet, right? But what we're seeing on these frozen planets is it must be sitting on water, maybe, because we're seeing subduction and tectonic plate activity on Europa. So it's just a really fantastic way for us to study how our planet formed by studying Europa. So that's a really interesting area to get into. And there are some of the images that the geologists use of photos from Europa. And we've only had these photos for a decade or so it's all fairly new information. Okay. Current research is into tectonics. Well, movement of Australia, we're heading northeast. There's lots of seismic activity. I may have mentioned last time. Does anyone ever remember Newcastle or heard of Newcastle in the late 80s, early 90s? Was it 89 maybe? 89, 90, there was a massive earthquake in Newcastle. What about those folk up there around Maxville? You would have heard about that. Your folks would be talking about it. Massive big earthquake. So we're not immune from, yeah, your dad was there. Yeah, so was I. Scary. Well, I was in Sydney, but still felt the aftershocks. So fracking, really dangerous mining practice. And also the evolution of our limbs is something that's coming out through this. So I'm going to stop. Now, you didn't have to soak in every word I said, but what I was trying to do, remember, excuse the pun, was just give you a bit of a feel for the landscape here, the scope of knowledge. Yeah. So if we go back to the start of the PowerPoint, I should do something better with these photos, shouldn't I? So I'm not doing this all the time. Remember I said we should look at these and we should be able to tell a story now about what's going on here. And I hope now that you can start looking at images like this. Yeah. There's another image there, isn't there? What have I done with it? There it is. Images like this and really expanding those stories with your knowledge. Okay. I have some questions and comments. Was this a useful exercise or did I waste your time? Waste your time. Is there anything else you want me to cover? Well, that's great. Thank you. It was good. I was good. I was God. I was God. Thanks, Maddie. Oh, good. Oh, give me a false sense there. False sense of my own importance. Yeah, don't call an atheist God. It's not cool. All right. I know what you've been waiting for, haven't you? If you've got to go, you got to go. But I'm ready to go to Kahoots. Okay. Now, all the Kahoots is publicly available. You can do it yourself. All right, because you can see my Kahoots. I've got one now for Threshold 4, which has 27 questions. 26 really, because one of them has to do with last year. If you've got to go, you've got to go. But if you want to play along with Kahoots, I will provide some commentary. I won't spend much time on the scores, but I will provide some commentary. If you don't want to play and just listen along, that's fine. But here we go. Jump on in. There's 16 of us. I'll need at least 8 to jump in before we play. Oof. Got 8. Fantastic. Yes, Sarah, there is. I'm sorry, this is it. I haven't got one. Oh, the threshold 5 one. Yes, there is. I'll get that done today. I'm sorry. I think I might have said that to you last week. Okay, Bryce. Great. Thanks for your questions, Bryce. Really appreciated that. Sarah, did you ask me about this last week or was it someone else? And I still haven't done it. It's just for lack of time. I should get it up today. I've got it. I've just got to convert it from last year into a new template and add some stuff. So, Sarah, it is coming. All right. Okay. Thanks, Sarah. It wasn't you, so I got 2 students on my assessment. That was so funny. It was a good one. Okay. Sorry. I just think that's funny. All right. Ready to play? Let's get going. Start off with a true and false. True or false. Yeah, that's it, folks. The universe is a great recycler. We were made from the leftovers of a supernova. Our solar system, our planet, our bodies, our world. Crazy. We'll skip over the scores a bit. Toilet paper's not in supply anymore, so it's lost its power as a prize. Right, accretion, and accretion is key to this, okay? Proplyd and protoplanetary disk are the same thing and they're used interchangeably. That's another really good image, okay? It shows a proplyd, doesn't it? So you should be able to explain a proplyd and the gassy giants out here and the rocky planets in here, yeah? Yep, chemically diverse. That's the key to all this, okay? And I've just put up MVEMJSUP, and that's my little mnemonic, if you like, a little memory tool. My very eager maid just swept up 9 pins. That's the planets: Mars, Venus, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. Pluto is not a planet. Well, it is a planet. It's not part of the solar system, right? Why? Because to be part of the solar system, you've got to be, the sun has to be your master, right? The sun is not Pluto's master. There's another celestial body that influences the orbit of Pluto as much as the sun does. So it is, the tribe has spoken, okay? The tribe has spoken on Pluto. It's got nothing to do with its size or whatever. It's just been asked to leave the island, right? It doesn't honour the sun as it should. It's been somewhat unfaithful, if you will, okay, to the solar system. There's something else influencing it, so that's why that's gone. But chemically diverse. But remember this, my very eager maid just swept up 9 pins, right? Sister Mary Elephant taught me that in like 1972, and I still remember it. So what is it then? Good question. What is Pluto? Mickey Speck Dog. No, it's just a planet. It's just a dwarf planet. Something of a meteor. Livia, you find out and tell us. Okay, there it is. The stellar winds, remember? Gassy giants in our solar system formed when the stellar winds blew away the gases from the rocky planet. So if we go, and that's a good accretion disk. If we go back to the previous picture, remember we had this protoplanetary disk flattening out and the rocky planets were already starting to form, right? And when the sun lit up, whoosh, all the gaseous stuff got pushed to the edges. Yes, Sarah, they are public. You can just search for them if you go to Discover in your own account, and my author name is Rafa J12, or you can just type in Threshold 4. There are others written by other people as well. Okay, it's not just me. Okay, the moon was formed. Yep, and the planet was Theia, right? And it was a collision, and we really need the moon. It does a lot of stuff for us. I'll try and skip through the scores a little. So Sarah, they are public. Really? Oh, okay. Oh, thanks, Sarah. I'll get into that straight away and fix it or check. My understanding was I'd made them all public. No, don't be sorry. Thanks for letting me know. Right, DNA is a very important part of our next story, okay? So which is not an ingredient for threshold 4. You can take this, what is an ingredient for threshold 4, and is newly formed stars, new chemical elements, and clouds of chemically rich matter, okay? So you can turn these questions around. Thanks, Sarah. I'll get onto that straight away. As soon as this is over. Oh, actually, I've got another. No, I'll do it at the end. Yeah, all good. Sorry, I just had thought it was done. Okay, again, turn this around. What is a Goldilocks condition? Gravity, accretion, random collisions. You'll be surprised how much random stuff happens in the universe. Totally random. Crazy stuff. Fantastic. Yes, that's what we're about. The solar system and the sun. Yep. Okay. Solar system and the Earth. That's what the new complexity is. Beautiful image of a protolid after the sun is ignited. Yep, a proplid, and it might be called a proplanetary disk as well. Let's have a look at that picture. Wow, just go back thinking about our sun igniting in the center of the proplid. Yeah, rocky planets enclosed, they've started to form already. Not like they look like now though, just red hot, molten, fiery rocks going around here. Yep, and the gaseous giants. So remember what I said about developing this into a story? These images should be really, really speaking to you now, or you should be able to add a lot to the image. Yes, it doesn't give us heat and light. It only reflects light, okay? No heat or light comes from the moon. It's just a reflection. So what is an effect of the moon? Tilt of the Earth? Yes, thanks to that collision. Stabilizes the Earth and its climate? Yes, it does. We'd be spinning wildly without the moon sort of affecting that spin. Controls the tides? Yes, but this needs to be modified. It controls the tides with the rotation of the Earth and the sun. Those elements also affect the tides. It's not just the moon. But good, well done. Let's have a look at the scores. Go Ryan, go Ryan. Yeah, I mentioned this earlier. It was the Hadean period. We're going to talk about the different eons and periods and ages and eras in a moment. Maddie, big winner, big climber. Yeah, the oceanic crust is. So if we look at this little image, okay, so there's the crust. Water weighs, this is a joy of the metric system, 1 kilo is equals 1 litre of water. 1 litre of water weighs a kilo. 1 kilo is the same as a litre of water in weight. The ocean's got salt and other minerals and organic matters in it, so it's heavy, slightly heavier. But there's the crust, right? So on the crust where we've got the ocean, it's obviously more pressure. Yeah, a planet. Think of it as a street cleaner. So our planet Earth was like a street cleaner during that, through that accretion ring. Okay, we've got the Kuiper belt, the asteroid belt, which is in our solar system, and it's just all the bits left over. There's no sort of asteroids field around us because our early Earth cleaned it out for us. Yeah. Okay. Yeah, the Andes. Let's have a look at the picture. Got an oceanic crust, hit a continental crust, and that's how we get the Andes. So having a good understanding of what caused the main mountain ranges in the world is very useful. What geological process caused them. Yep, the Himalayas, yay! 2 continental plates came together for the Himalayas. So understanding the geological heritage of mountain ranges is very useful to your story. Ooh, Ryan doesn't want to give up the lead. The core, yeah. Iron and nickel is made up the core of the Earth. They're the heavier elements. So core, inner core, mantle, sometimes we refer to the outer mantle and the crust. Nickel and iron, right? The heavier stuff is sunk to the center. Very important for our electromagnetic field. Excellent. Okay, we've got to get a good understanding of the different layers, and there's the crust, and then we have another really thin layer around off the crust called our biosphere, and even within our biosphere that's leveled. But our biosphere is really, really thin. Not from where we're standing, but in the old days before COVID-19, and you'd look up into the sky and you'd see one of those jet planes flying around. You'll have to explain to your children what they were, probably. You know, they cruise at what, 30,000 feet? That's about 10 kilometres, 10 or 12 kilometres in the air. And you think they're high up? Well, they're only a third of the way through our atmosphere. You know what I mean? So if you've got ground level and our atmosphere, when you see those jetliners, they cruise about a third of the way up the atmosphere. There's another 2/3 of the atmosphere to go. The basalts are the lighter rocks, okay? We do have iron on the surface and near the surface, but most of it's in the center. Good. Right, the lightest materials is the atmosphere, and even that's layered. Okay, cool. Go, Liv, go, Liesl. Can we catch Kiara? Yeah, 4.567. Sometimes that gets rounded up to 4.6. Don't get too distressed. But yes, 4.5 billion years. And we can tell because of radioactive decay of molecules and elements, okay? So we can do that pretty precisely. Remember, this is an evidence-based story. Okay, yeah, it's a bit of a guess for this one, but we do have geological time, and we are going to get to know them, the different eons, eras, periods and ages, all right? Especially important for understanding when we start looking at life, okay? Because once life starts, the ages and eras break up really quickly, yeah? So we're here in the Holocene and we're entering the Anthropocene, but we'll go back through here. I'm a bit nerdy, and one of the reasons I don't like Jurassic Park is because they mixed up their periods. They called it Jurassic Park, but most of the animals or dinosaurs they supposedly revived and did all that sort of stuff. It wasn't a documentary, by the way, but they did muck up their periods. That most of what you saw in Jurassic was actually from the Triassic period. It annoys me. Sorry. Did anyone else get angry with that? Was it just me and a bunch of other nerds? Okay. Bad science literacy, I say. Promoting bad literacy. Right. Yes, good to know. 99% of everything, 99.9% of all went into the sun. It's not just the sun's big, it's incredibly dense, huge mass, right? Massive, okay? So 0.1% made up everything else. Of that 0.1%, 99% of it went into the gaseous giants, meaning everything else, I'm not talking about Pluto, don't like Pluto, everything else, the rocky planets, the asteroids, comets, everything else, 0.01%. So we're tiny. Go Ryan, draw me home. Yes, well done. Hydrogen is the most common element, abundant element in the universe. Always has, always will, probably. Ah, very good. Wagner. Someone was telling me yesterday in one of the groups that if you go into Google and just type song and Alfred Wagner, there's a little song about him. So that'll be cool, I guess. Okay, getting close to the end now, folks. Yes, the Pacific Ocean is getting bigger, that's for sure. Mim might like to comment on that, but it's not a piece of evidence for plate tectonics. Tropical fossils in the Arctic are evidence of plate tectonics. Similar geological structures, rock layers, is evidence, and seafloor spreading is evidence of plate tectonics. Ooh, I think Kiara's going to win. The last question, because the next one's got to be updated from last year. Yes, it was Hess. So learn about Wagner and Hess. We'll skip this question because it was about last year when you had to write a journal. Year before, actually. Skip that. Next. Okay. No toilet paper today because it's back in the supermarket. Well done, Liesl. Ryan. Woo. Da-da-da. Special mention to Maddie and Jess. Good job. That was fun. Okay. I'm done. We'll hang around if you have questions, but I hope that was useful and hope it gave you some good scope to the type of knowledge you got to get your head across. Sarah, I'll get into my Kahoots now and make these public, discoverable at least. I'm sorry that I hadn't done that before. We're very happy to check your assessment 3 drafts. Please don't ask me to check your ass though. So, you know, please check my, sorry, can't do that. Even if it is attached. I crack myself up sometimes. So I'll just see what's going on here, Sarah, but please, questions, comments, happy to hear them. No worries, Maddie. Thanks, Jess. No problem. Hope it was informative. Questions or comments, anyone? People are jumping out of the room quick smart. I guess they had enough. Just you and me, Min. No, Kiara's still there. Well done, Kiara. Oh, all gone. Hey, Min. How you doing?
Hello. They jumped out of there quick.
Yeah, I went a bit longer than normal.
So
I'm just going to stop the